Hello viewers, in today's session we are going to discuss another important problem from functional equations. So here we have to solve this problem in which we are given a function f from r to r, where r is the set of real numbers, and we have this equation f of x plus y is equal to f of x plus f of y plus 3xy minus 4 for all values of x and y belonging to the set of real numbers. And here we are also given that the function f of x is differentiable, and f prime of 0 is given as e, where e is the exponential number. Then we have to find f of x, right? So let us start. So before solving this problem, let us quickly see the definition of derivative of a function, which is also known as a first principle, right? So the derivative, that is f prime of x, is given by this limit, that is limit h tends to 0. We have f of x plus h minus f of x divided by h, right? So here to solve this problem, we'll utilize this definition, and if we take x is equal to 0 here, then the derivative at x is equal to 0 is given by this limit, that is limit h tends to 0, and here we have 0 plus h, which is simply h, and here we have f of 0 divided by h, right? So these two important concepts are going to be used while solving this problem. So now let us write this equation, that is f of x plus y is equal to fx plus fy plus 3xy minus 4, right? Now let us substitute x is equal to 0 and y is equal to 0 in this equation. So we'll get f of 0 plus 0, and here we have f of 0 plus f of 0, and here we have 3 times 0 times 0, and here we have 4. So this is f of 0, and here we have 2 times f of 0, and this is 0 minus 4. So we can take this term to the left hand side. So we have 2 times f of 0, and here we have 0 minus 4, that is minus 4. So 1f0 minus 2f of 0 is minus f of 0, and this is equal to minus 4, right? So minus and minus get cancelled, so we have now f of 0 is equal to 4, right? So we'll utilize this value when we find f prime of 0, because here we have f of 0, so we'll substitute f of 0 is equal to 4 over here. So now let us come to the definition of the derivative. So we have f prime of x is equal to limit h tends to 0. We have f of x plus h minus f of x divided by h. And remember, this h is infinitesimally very small, and it is a positive quantity, right? So okay, so now here we have this term, that is f of x plus h. So f of x plus h can be obtained by using the given equation. So here we have f of x plus y, and here we have f of x plus h. So now if we replace here y by h, then f of x plus h can be written like this: f of x, here we have f of y, y can be replaced by h, and here we have 3xh minus 4. So let us substitute this value over here. So we have f prime of x and limit h tends to 0, and we have f of x plus f of h, plus 3xh minus 4, and here we have minus f of x, and in the denominator we have h. Now f of x and f of x get cancelled, so we are left with limit h tends to 0, f of h plus 3xh minus 4 divided by h. So now let us combine these two terms, and for 4 we can now write f of 0. So we have limit h tends to 0, f of h minus 4, and here we have 3xh divided by h. So this is now limit h tends to 0. Now from here we can break this expression. So we have f of h minus 4 over h plus limit h tends to 0, 3xh divided by h. So now we have limit h tends to 0, f of h minus, for 4 we can write f of 0, and here we have h, and here we have limit h tends to 0, h and h get cancelled, so we have simply 3x. Now 3x is independent of h, so now here we can simply write 3x, and for this expression we can write f prime of 0. So here we have f prime of 0. So now f prime of x is equal to f prime of 0 plus 3x. So now we have f prime of x is equal to f prime of 0 plus 3x. Now we are given that f prime of 0 is equal to e. So substituting here e, we can now write f prime of x is equal to e plus 3x. Now see, the right hand side is a linear function, and here we have the derivative of f of x. So this is a differential equation, and now we have to solve this differential equation by integrating both sides. So we can now integrate both sides. So we have here integral f prime of x dx, and here we have e plus 3x dx, and c is the constant of integration. So integral of f prime x dx is simply the function f of x, and here the integral e dx is simply ex, and here the integral of x is x square over 2. So we have 3x square over 2, and c is the constant of integration. So this is the form of the function f of x, and here now we have to find out the value of this constant of integration c by using this condition. So we are given f of 0 is equal to 4, so it implies we have to take x is equal to 0, right? So when we take x is equal to 0 in this equation, we have f of 0, and here we have e times 0, then 3 times 0 square over 2 plus c, and f of 0 is 4. So here we have 4, and here this is 0, this term is 0, and here we have c. So c is equal to 4, right? So the constant of integration c is equal to 4. So substituting over here, we have f of x is equal to 3x square over 2 plus ex plus 4, right? So this is the required function, that is f of x, and from here we can easily conclude that this is a quadratic function. So viewers, this is how by using these simple concepts we can easily solve these kind of problems.